Good evening, ladies and gentlemen. Tonight we'll be looking at the binomial coefficients. We saw these show up in our introduction to the binomial theorem in the previous video, but we're going to talk a little bit more in depth about where they come from and how to find them. So, first thing we have to establish is what n means. Well, it's not really n yelling, but it's n factorial, n exclamation point. This exclamation point is called a factorial. So what does it mean? Well, it means we do 1 times 2 times 3 all the way up until that number, or you can think of it as that number times every whole number less than it. So 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Another useful note, something that we should pay attention to, is what 0 factorial is equal to. 0 factorial is equal to 1. There are some explanations for why this is, not something that I'm going to go into on this video. A quick YouTube search should find you some different explanations. A real simple explanation is mathematicians defined this to be true because it was useful to them. So, interesting little note there. But know that 0 factorial is equal to 1. So here's Pascal's triangle. We looked at this in the previous video. These were our binomial coefficients. And I showed you this calculation in our calculator. N choose R. And take note that the same place that we found this in the probability menu, you can also find your factorial command. So this is the 0 row, the first row, the second row, and we talked that the calculations was 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. 4 choose 1, 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, and so on. Well, let's look at where these actually come from. There's got to be a nice formula, and there is. And you're thinking, that's not a nice formula, Mr. Schnack. That's the ugliest formula I've ever seen. It looks like a bunch of angry letters yelling at me. It looks like a formula my parents would come up with. But it's actually not bad to use, and some real nice things happen when we put numbers into it. And we'll see that in just a second. But some things worth noting. N choose 0. Any number choose 0 is 1. We can see that in Pascal's triangle. These are all something choose 0. 5 choose 0, 4 choose 0, 3 choose 0, so on. And anything choose 1 is that number. 5, 4, 3, 2, 1. 1 choose 1, 2 choose 1, 3 choose 1, 4 choose 1, 5 choose 1. And this one isn't as important, but anything choose 2 will be n times n minus 1 over 2. And there's actually one that I like to think of and remember. N choose n is also equal to 1. So these are useful, but we can always find them using our formula up here. So let's evaluate 6 choose 4. Okay, so that formula says, and remember this is like the n, this is the r, and this was equal to, if you don't remember, let's flip back to our notes, n factorial over r factorial n minus r factorial. So this is going to equal 6 factorial over 4 factorial times 6 minus 4 factorial. Now, you might be tempted to just grab a calculator, but guys, this is the kind of thing that you'd be expected to do without one, with these kind of numbers. And we can do that. And watch how. 6 factorial is 6 times 5 times 4 times 3 times, and I could keep going. But I'm going to stop here and say that it's times 4 factorial. Why, you may ask? Well, because there's a 4 factorial in the denominator. And what happens when we're multiplying by the same thing in the numerator and denominator? Hope you're thinking those are going to cross out, because this is multiplication, baby. And then 6 minus 4, that's 2 factorial. Okay, so 4's are gone. In the numerator, we just have 30. Denominator, 2 factorial is 2 times 1. And 2 times 1 is 2. 30 divided by 2 is 15. Da-da-da! There we go. Not so bad. The trick is stopping this numerator's expansion when you get to a number that will cancel with what's in the bottom. Sometimes it's going to cancel with this number, Sometimes with the n minus r, it depends on which one is bigger. So that'll be fun for you to try. Let's look at this problem. The expansion of 1 plus x to the n, don't know n, up to the third term is given by 1 plus 6x plus ax squared. Find the value of n and of a. Ooh. Okay, so let's think about what this binomial expansion would be. So it's going to be n choose 0 times 1 to the n times x to the 0 plus n choose 1 times 1 to the n minus 1 times x to the first plus n choose 2 times 1 to the n minus 2 times x squared plus data, 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 data. And it goes on and on and on. Now notice all of these exponents do add up to n, which is what we saw in the previous video. Now this equals 1 plus 6x plus ax squared. Okay, let's clean this up a little bit. N choose 0, that's 1. 1 to the n, well that's also 1. X to the 0, anything to the 0 power, guess what, it's 1. Cool. N choose 1, that's just n. Times 1 to any power, that's 1, times x. Okay, so there's my second term. And then n choose 2. Now, you might remember the formula that was on a couple slides ago. If you don't, guess what, that's okay. N factorial over 2 factorial n minus 1 n minus 2 factorial. And that's going to simplify down pretty nicely in just a second. Times 1 to any power is 1, times x squared. Let's keep cleaning. First term is 1 plus n times x plus, now we got to work with this a little bit. N factorial is n times n minus 1, that's an integer 1 less than n, times an integer that's 1 less than that, so n minus 2 factorial, over 2 factorial is 2, times n minus 2 factorial. And boom, those are gone, times x squared. So this becomes 1 plus nx plus n times n minus 1 over 2 x squared, and that has to equal 1 plus 6x plus ax squared. All right, so how does that help me, you might ask? Well, n, that coefficient, the coefficient of x, has to equal the coefficient of the x over here. So guess what, ladies and gentlemen? We now know that n equals 6. Cool. We also know that a is more than what a Canadian says, but a, this a right here, that has to equal this coefficient of x squared, n times n minus 1 over 2. Well, we know that n is 6, so a is 6 times 5, n minus 1, divided by 2. That's 30 over 2. A is 15. We have our two numbers. We are good to go. We are rocking. So there we have it. N is 6, A is 15. We are done with this problem. Tonight's been a joy. I hope you had as much fun as I did.